Okay, are we live? Got everything but video. Okay, let's get cracking. And record. Welcome everyone to Mark Void's Another Warranty. And today we've got something exciting. A little exciting for my wife. We're getting rid of an old laptop that I've had sitting around collecting dust for quite some time. I mean, it's heavy, it's thick, it's got Windows 8. I mean, this thing's ready to go, right? There's some interesting tech, interesting design choices. I mean, as far as PCB design goes, inside a laptop computer, I mean, it's hard to beat it. You really kind of have to know what you're doing to be able to get these things built economically in a decent time frame. So there's, a few dozen engineers overseas that do that. Let's go and get started. I'm going to switch to a top-down view in our new camera system. We are on a fancy silicone mat. Keep the noise down, but I know that ends up just having you guys stare at a dark screen. So we're going to do some of this as though we're going to put this laptop back together, although this laptop will never be put back together. And what we're going to start doing is pulling out case screws. Now, if we were putting this back together, we would need to keep track of which screw comes out of which hole, because sometimes they're of different length. And if you're not careful, especially on newer model laptops, you'll get a screw that's, call it 4 millimeters long, and you put it into a spot that's meant for a 2 millimeter long screw. And those numbers are, by the way, very, very small, but I'm just saying, you put a big screw into a little hole, gonna make a big hole. And you don't want that. And typically the way to avoid that is to carefully extract these screws and keep a track of which one's in which hole. A lot of different techniques you can use for that. If I was going to worry about it, I would probably put each of these screws in little bins and maybe some bits of colored tape on the holes that they belong to. Could always use a Sharpie. I mean, just whatever you can. Heck, you can even just take notes. Whatever it is that you can do to keep track of them, though, that's what you should do. I keep a magnet on the bottom of my Leatherman, so if I ever do want to screw out of a hole, I can just tap it. So, give you an idea of the size that we're talking about here. These are little itty bitty baby screws. And as far as measurements go, this is a 6 millimeter long by, it's like an M2, and by the thread pitch, I'm guessing it's an M2. Oh, sorry, I was a little off screen there. So I was just looking at the diameter compared to the length. So it's about a 2 millimeter by 6 millimeter screw. So it's an M2 by probably by 1 by 6. And the other ones that I'm able to pull out so far are identically dimensioned. So the good news is I could put any one of these in any one of the holes and I would get similar results. And it could just be the case that every single one of these is the same length. This is an older laptop. And it's got plenty of meat to it. The designer certainly could have done that without any troubles at all. So, there are the majority of our case screws out. We're going to keep digging here. This was back in the day that laptops were big enough that you could have more than one disk drive in there. And I don't really remember what's in here. I know I put Linux on it at some point because it lost its ability to run Windows after a while. So we've got a panel removed. Looks like we've got a little bit of memory. We can take a look at that in a second. There's memory up here. Wi-Fi and wireless down here. We can go ahead and pull that out. Man, this is going to provide us so much that we can look at. Looks like it's got 2 antennas, but only one was connected. Don't know what that was about. I'm having a little trouble squeezing that because I've got fat fingers. There we go. So we might be able to take that apart at some point and see what's inside. For those of you who can't make it out because you're zoomed out or you've got a small screen, this is the module I'm talking about. And I was just noticing 2 of these little I forget if those aren't SMA. What are those? I forget the name of these. Those little connectors on it, but only 1 antenna cable. So no diversity antennas there. All right, looks like it's a good thing we pulled off that because there's a couple more case screws that we would have missed. Okay. Let's see if there's anything that I can't see that maybe you can, so you guys don't yell at me through the internet. Yep, there's another one. There's another 2. All right. How much fun is this? I don't know what you guys do with laptops once you're done with them. I try to run them until they die, so there isn't any really discrepancy. This particular one kind of died a slow death. It just stopped running Windows. I mean, it just became too much for it. Something happened deep inside its internals. But then I gave it a second life on Linux. I had an Ubuntu solution going there for the longest time. And at the point that I got a new laptop, that became less of an issue, especially since I could run the Windows subsystem for Linux and do some of the stuff that I wanted to do. So I currently have no dual boot computers going anymore. I do have some mini PCs that I have Linux on, but you know, different flavors, different things. I've got it for some software-defined radio. Right now, I'm just going through and looking for any case screws or anything. I mean, usually there's a little bit of trim that holds this stuff together too. I'll show you in just a second. For anything else that might be holding this together, here is a DVD writer, I'm sure, that that we can pull out. And it gives us an idea of the date. This DVD writer is from March 2014. So 9 years is kind of ancient in the laptop world, but it wouldn't necessarily be ancient if this thing still worked appreciably. Sometimes there's screws hidden beneath stickers. And before I start popping this open, I have a tendency to kind of Hulk smash. So before I pop this open, I just want to make sure that there's none that I'm missing. There's also could be some underneath the feet, but with as many case screws as I've already discovered, I wouldn't expect that just yet. Oftentimes, too, when you're taking things apart, you'll find a trim piece up at the top or at or above the keyboard level that has some things in it that you sometimes have to pop. I am Hulk smashing as carefully as I can, but there's a reason I don't have nice things. Also a reason I don't often take laptops apart. Every now and again I can't get it back together. Okay, so hiding up here we've got a couple ZIF sockets, zero insertion force. Gonna have to figure out what's holding that one on. And then, oh, here it is. So all you have to do is just carefully flip that, and then you can, oh, or is that a different one? It's this one. And then once you separate those, you start having a party. All right, so the first board out is keyboard and touchpad controller. So we've separated that with a couple connectors. Power switch, it might be something we'll look at in a little bit. It looks like they did some interesting things with this cap touch PCB, and we might want to look at that, but we'll set that aside for now. All right, what else do we have going on here? We need to back up and look at the internals. So we've got a fan blowing over a vent. I bet this is going to be connected to some heat pipes. I hope so. Those are always fun. I like getting those and showing them off to people. Something you don't see too often. Actually, no, I think I just looked at that board wrong. So I'm just going to start taking things off. We have an SD card reader here at the front. So just removing the screws that hold that in place. It's got a covered flat flexible cable that's covered in aluminum. I mean, it makes sense from a signal integrity standpoint, but I assume, since it's not grounded or anything, this was a complete afterthought, that this was some sort of a something they had to do to stay EMC compliant. I don't know. I've not really noticed that before in other designs. I have seen shielded flat flexible cables before, but usually they're shielded to ground. They're not just shielded for, you know, for the fun of it. So that's what makes me think this might have been an afterthought, fixing a problem that was there. And a SD card reader. Big. I mean, everything nowadays is so small. Usually don't see the full size ones anymore, but huh. There it is. Little Kapton tape covering it. Nothing to it at all. All right. We've got a piece of plastic with some X's cut in it. I really couldn't begin to tell you what the X's are for. I guess stress relief. Interesting. And then we're back to the board. I still have some more flat flexible cables, FFCs. Another one covered in some sort of a metallic tape, except in this case, we just have it on the one side. It does stop before the plastic stiffeners, but I don't know. I'm going to have to look into that later and see if I can learn more about that. That's unusual. Unusual. We've got the hard drive. They sure didn't make that easy to come out, right? Look at how much we've had to disassemble just to get there. They could have made an opening through the bottom and made that a whole lot easier to get out if they wanted to. They certainly didn't want to. Okay, so that's the hard drive. What did we have in here? Solid state drive. I was just looking for anything to give me an indication of date. And nothing really is, I mean, it's there, I just can't see. 2014 again. Data manufacturer to 2014. So gosh, 2014 was quite the year in the Mark household. A lot of stuff going on. Life's a lot calmer now. All right, another FFC, except this one terminates inside a connector for the hard drive. Interesting. I haven't seen one terminate right inside of, I guess bring it back up on the screen there. Or maybe this one was for the CD, but I haven't really seen one that terminates inside the housing of a data connector. I mean, it's built in, so that makes this custom, which makes it expensive. So they must really needed to have saved that space to go to the effort of having that manufactured. Toss that aside. Let's keep going. Oh, we've got what I'm guessing is one of the speakers. Let's see, or it could be something else. I'll know once I get it out. Or is it, maybe it's underneath the motherboard. Maybe I better keep removing screws. A lot of times people give you a laptop to repair. They've done something to it to damage it. Water is a common one. Maybe somebody stepped on it or got too hot. I don't really know what happened to this one. It just kind of slowly lost efficiency over time. It could very well be that that it just developed some issues internally from thermal cycling. These boards are put through a lot of thermal stress, and over time the varying coefficients of thermal expansion between the copper and the dielectric causes the boards to fail. It's unfortunate, but it happens. And then I see something, once we get this board out, I see something that amuses me that I'll point out to you. And again, you guys are, since you're staring straight down at this, you're probably seeing the screws that I'm missing. But all I have operating right now is a tiny little monitor up into the corner there. So I can see that I'm broadcasting and I can see what camera's live, but I can't really see what that camera's showing. Come on. Looks like it's caught on the case, but it should be able to easily remove, provided I haven't forgotten something. That makes me think I've missed something. And it's underneath. Is it something I missed from the bottom? It is. Oh, it's a routing wire. Oh, well, let's just pop that. We don't need those. Okay, we're coming back for the screen in a minute. But here is our motherboard, such that it may be, and it's got some interesting things on there we'll point out in just a minute. Thermal management is neat. Now, I saw this on the last teardown I did. Right in here, there is a structural stiffener that is a little bigger than it necessarily needs to be. Made out of metal that's a little heavier than it needs to be made out of. And filling some spots where it doesn't do much in the way of adding structure. This, my friends, is a value-added mass. This gives the device weight, except it's a laptop. But, you know, people associate, you know, weight with expense, and that's great and all, but this is a laptop. Why are we making it heavier than it needs to be? I mean, they could have rolled some sheet. This is a plastic-framed laptop. It's not an expensive one, but they could have rolled some sheet metal in there and done something else. We've got little bits of... this is just plastic. This is all, I suspect, aesthetic. I guess it might keep out some of the larger debris and keep insects from crawling inside the vent holes, but it's only on some of the vents, so I don't know about that. It's another custom molded connector for the hard drive. There we can see that a little better. And then on the other end, we've got plug for the board. Nothing too exciting there. Okay. Moving over. This is the reason I couldn't get this out earlier, was there was a screw hiding from me. Now, if you ever get a screw that you can't get out, and I've got one, these tools right here, they're called Vampliers. They come in a few different sizes, and Vampliers have threads in two locations that it matters. One is right in the tip of the screw, so it can grab screws. Right, so if you look at it this way, you can get it right in there. It'd help if I zoomed out. I'll do that for you at some point here. Okay, once that's loose, your screwdriver is working again. And there is one of the speakers. Here is the second one. I've always wondered how they designed these little cavity speakers. I mean, it kind of looks to me like they just filled in whatever space that they had, and they figured, hey, that'll be good enough. We'll fix everything else with software processing, I guess. I don't know. But the two speakers seem to have little resemblance to each other. I mean, there's a back cavity for each one. I mean, I don't know how they design these things. If you get an audio engineer in there that does it, or if they just figure, there's some empty space, let's mold a cavity there, put a speaker in it, and call it a day. I don't know. Be interesting to find out. Okay. As we continue our teardown, what's left in this main thing are some hinge screws. Once we release these, we should have access to the monitor. Now, theoretically, you know, this monitor with touchpad, there's not a thing wrong with it. But I don't know that I could ever really find a use for it. Monitors and touchpads are so cheap these days. You know, you can pick one up that's probably brighter and better resolution, and you can easily get a video driver for it, and it's all much easier than trying to repurpose one, which is what I would have done years ago. But tracking down the data sheets and, you know, with everything as small as it is, you know, spinning up your own board to create an interface for all this, it's, you know, unfortunately it's cheaper just to go to offshore and get something. It's ready to go. You don't have to mess around with. Okay, so we've got probably tape holding all of that in, and it's not going to want to come out easily. So I wonder if the back is just... So it could be that this thing is put together in a way that's going to... I would have to spend more time than I want to spend to take it apart. Right? If this is glued in, if this frame is glued in and then there's screws underneath it, I would heat this up and I would carefully pry under all the corners, and I would try to remove it. I don't know if that's the case or if it simply just splits it. It looks like it just splits here. Okay. So here is our display. Here's the back part of it. It just has a big piece of aluminum. Oh, that's nice. It even tells you replace with spare. See, check that out. Oh, can you see it? There it is. It tells you what to replace with. That's neat. There's a webcam in here that I don't know how it was attached, but it isn't anymore. I just ripped that right off. Whoops. Oh well. That's again where I'm a little too good at Hulk smash when I take these things apart. And also coming to inspect there is our friend Chester the cat. He approves and took off. All right. We're cruising. Right now I'm just taking the rest of the hinge screws off of the laptop. Nothing too exciting. We'll hopefully get to some exciting stuff here in a minute. This is just grunt work. For those of you that are just joining us, we're doing something called Mark Voids a Warranty, where I take a beloved electronic device and destroy it. For science. Right? For science. This is an old laptop that doesn't really work anymore. It slowly died over time, and I'm just going at it to see what there is that we can learn from some of these devices. And I'm right now interested in the circuit board or boards that power this particular display. That's what we're going to look at next. I think if you have questions, there is a way to ask them in the chat. I see somebody has chatted me, but I believe it is a coworker who I am choosing to ignore at the moment. Okay. Get rid of that. So what we have here is a bit of remarkable printed circuit board manufacturing and assembly. And I'm going to have to destroy a little bit of it and make it in such a manner that it will never run again, so that you and I can see what's going on. And we now get to take a look at this cool circuit board. This is not your standard 1.6 mil thick board. This is one of the thinner ones that we can make. I don't know if I have any calipers handy, but I would say this thing is sub 40 mil board. It is tiny. It is thin. it's probably only a layer. I mean, well, it's probably, I know it's at least 2 layers. I would suspect it's only 2 layers. We would have to pull out a microscope to look at that edge to see if I can see any more copper. But what you've got here are a series of really, really, really tiny traces. And I'm going to see if I can focus on that with you with the microscope one. Sorry about that. Might just have to move the board. I don't have the dexterity of the microscope. See all these crazy, crazy, crazy fine traces? Well, those are connected, these little gold fingers are connected to traces in parts of this that lead back and run signals. And then these connect to the LCD on the other side. Those tiny, tiny little guys. So let's get our focus back, and then we will this thing is so touchy. There we go. So these things are interesting. So the first thing that I notice is that this particular board has test points all over it. And it also has what appears to be a few unpopulated parts. So the little round things are test points. And that's a problem for a board that's this thin because it is so easy to apply pressure and bend the board. So I'm sure this thing is built with, it's put in something with a huge backing plate, some big steel backing plate. Notice there's no assembly, no silk screen. The only thing on the back of this board is solder mask to protect the traces. But they've not put any parts, no test points, nothing on the back side of this. And that's hard to do, but that's smart because that saves you all sorts of expenses. One of the troubles that you have with boards that are this thin is, one, putting on connectors so they don't fall off or break the board when you're doing it or just tear off. And they used a 0 insertion force connector for that. Another issue that you have, like here, they put an inductor on this thing. I mean, a lot of the parts that they have, you really have to be careful. Size was an issue here. That's why they made this board so thin. They didn't want to make the device too thick. Well, inductors, ICs, they become thicker than the board that you have in situations like that. There are some interesting things that I think we should look at, but let's keep tearing this stuff down and see what else there is to find first. All right? We've got our friend Chester Cat telling us that he's not happy with life right now. He might just come over and see what we're doing. Okay, here's another board. This is still off of the monitor. This may or may not be the touchscreen controller. I'm not entirely sure yet. We'll have to do a little bit more digging. But check that custom IC out in the middle. That is a really unusual footprint. I'd be interested to look up and see what that is later. That is one of the most, I just would say, rectangular, highest aspect ratio ICs I think I've ever seen. That doesn't have magnetics in it or something. So, all right, let's keep going. We've got some screws holding the rest of this display. In place, so I'm just going to keep removing those, and like I said, I have no intention of putting this back together, so I'm not being as careful as I normally would. But even when I am careful, the tendency of me to smash stuff unintentionally is pretty high, so I don't think I would make it in the laptop repair business. our friends that do that have my respect. I just have trouble seeing anymore, and finding parts is a pain, and people always want stuff yesterday. Keeping my cats from crawling around in my electronic devices is also a trick. They like to play if I fits, I sits with anything of value in this office. Okay, we are making good progress. Only a couple screws left, and we should have this free. Keeping track of what screws go where on a repair is a pain. You can get these little silicone mats that have index boxes in them, so you can keep track of the order in which you pull stuff out. You can always, if you want to, you can always videotape everything that you do, but then you got to videotape the stuff going, watch it play it back when you put it back in. That's always a good way. So here is our screen. There's interesting stuff in there. I've just never found a really good way to do it. It always is more tedious and time-consuming than it needs to be, or you make mistakes. All right. Here is our screen. It is... Yep, that board with the weird aspect ratio I see was the touchpad controller. It connects to it right here. So this is just, I'm guessing cap touch, capacitive touch. Maybe we'll find out later. Maybe we won't. Let's continue with the teardown. Now, screens are made in lots of different ways today, but back in 2014, they were all mostly made the same. And, OLEDs and all that weren't in laptops yet. So these things all have LED illumination. They've got a piece of plastic that disperses the light from the edges. They've got a couple pieces of diffraction grating in them to spread the light out so that you get even illumination. All I'm doing right now is trying to remove a aluminum. This is actually a nicer screen than you usually see. I mean, they actually made a frame and put it all together. A lot of times you'll see these components simply just taped together on the lower end stuff. They don't bother even trying, really. But LG went above and beyond. Okay. Now, you shine light from the bottom with LEDs or halogens. Then it hits a piece of plastic, and that plastic spreads the light out. You can also see some diffractive characteristics on this. The whole idea is that when the light hits it, that the light shoots out the sides. There was a piece of white plastic on the back just to keep the light going in one direction, reflected in one direction. And then we've got a diffusion screen, a diffraction screen. Ooh, whoa. Let's see what let's see. Well, wrong one. Here we go. Whoa. Oh, yeah. This is fun. What should we do with it? I don't know, but that is a cool video effect. It probably is great that I keep getting my fingerprints all over this. Let's stop. Okay. Sometimes there's two diffractions. Yep. Two diffracting screens. And then I've already broken it because I'm such a cretin, but here is our LCD. So inside there's these So with LCDs, you've got polarizing filters on either side so you can't see through, and then these little crystals on the inside. And when you apply electricity to them, they twist and they turn and they let light through. So as you can see here, I've damaged them. I Hulk smashed at some point. Didn't even realize it. I don't even know if I heard it, but I'm certainly responsible for that at some point. But anyways, you've got these really, really, really tiny pieces of glass, plastic that operates as a polarizing filter, and those crystals hiding inside. So that is it for the screen technology, but not for the screen printed circuit boards. Now, let's get over here and see what we've got going on. This is actually some of my favorite technology. It's really cool. It's something called a heat pipe, and whoever invented it deserves a raise. You see, copper can only move so much heat around. I want to, off the top of my head, and I could be wrong, but I want to say the thermal conductivity of copper is 400 watts per meter Kelvin. Let's just say that's right for now. Okay, that is the most conductive metal, second only to silver, which is, you know, a marginal improvement. Let's call it 412 watts per meter Kelvin. I don't even know. Most printed circuit board materials is lucky to have a thermal conductivity of like 0.4 watts per meter Kelvin. Okay? It's 2 orders of magnitude less. Well, when we get moving over to heat pipes, and not this particular one, this one's much too small, but some heat pipes have a thermal conductivity of, you know, 40,000 watts per meter Kelvin. A 2 order of magnitude increase. And the way they get away with that is by taking advantage of phase change. So inside this pipe, it's likely not just a piece of copper. It's, in fact, I can tell you it's not looking at this. What it is it's a hollow cavity with some, forget if it's sintered or how they get, but basically copper mesh inside. And inside of that is a chemical of some sort. And what happens over here on the compressor side, on the hot side, is the liquid that's in there vaporizes. And it travels over into the evaporator side, the cooler side, where it goes into these fins and air is blown through, and that causes it all to cool off and condense, at which point it travels back, and inside everything that's happening here is completely passive. The only moving part of this heat exchanger is the fan. So again, over here on the hot side, the liquid evaporates. It'll travel in its gaseous form over to these fins where air will blow past here. The heat will go out into the environment. It'll cool down, it'll condense, and then it'll travel back over to the IC where it's keeping everything nice and cool. So, we just got another question in asking if this is recording, and the answer is yes. Yes, it is. And what we'll do in a day or two after YouTube processes it is we will figure out how to edit it down, you know, cut parts out that we don't need. We'll make that somebody else's job, of course, and that'll do it. So anyhow, thermal heat pipes. All right. Now, separating the men from the boys, the women from the girls, the men from the women. I mean, the people who really have to know what they're doing, who really have a job ahead of them, are people that lay out printed circuit boards designed for computers. There's so much going on these things that, you know, space is always a premium. You've got to worry about vias. You've got to worry about multi-layers. You're doing sequential stack-ups that have blind that have buried, that have, I mean, just all sorts of stuff's going on. You really have to keep track of a lot of stuff. It's a pain in the butt. One mistake can kill you. You can't really afford it. So the people that put these together, I've got nothing but the highest respect for. It is one heck of a job. I'm going to go ahead and pull off that battery. So what we're looking at is a computer, the motherboard for a computer that was made in 2014. So it's not that old technology. A lot of the same stuff's on. What I'm looking at here is what I believe to be a zero insertion force connector with just a single cam. So by pulling that out, I guess I should show that to you on the close-up cam. So we've got a little rotating locking cam. So I'm going to rotate it to hopefully the unlocked position. So we can see the backside of this IC. Looks like we see some traces on it, and we see a ton of test points right there. Man, I'm glad I'm not the guy who has to jig and fixture that. Yeah, there it is. How pretty is that? Man, that's a lot of connections, and every single one of those has to be routed. That is cool looking. I don't know what I'm going to do with that, but I'm not getting rid of that. Just the way the light bounces off of it. I like. Wow. Now, going back to here, I mean, those look like test points to me. So somebody built a jig that must just be incredibly tiny to be able to tap those. If they, well, I guess I'm assuming they tap them all at the same time. I don't know that that's true. But each pogo pin that you have is about 1 Newton of force, and that adds up fast, especially something like that that has so many connectors. All right, so it looks like that should allow me to take a, well, maybe not. I'm wondering if it'll allow me to take off that that ZIF socket. I doubt it. Nope. There it comes. Come on. We don't care if you go back together or not. So inside this ZIF socket, you've got the contacts for each and every one of these things. Every one of those pins. And the way that it's locked in is there's this little grid, and when you shift it, all it does is just move over, and it just captures each one of those things with a shear force. So the pins go through the holes, and they slide against each other, and then they get caught in there. So you can, I mean, you can do a couple interesting things. One, with a connector that's that big, I'm sorry, an IC that's that big, it would be very easy for it to, you know, get damaged. If you got a pin bent or something, it'd be a pain. But if you put that through the reflow oven, it could get damaged. Well, let's say we don't want to do that. We just use the ZIF connector after the fact. Or if you want to upgrade, you want to have different values of different types of integrated circuits that are pin compatible but have different capabilities. I can't get that screw out, guys. I am sorry. Oh well. I tried. Get that off of there. We can see some other things here. There's a missing ball grid array. Let me see if I can get focus going for you. So this was designed to accept something. I mean, I don't know what that particular IC did. We could probably get some hints if we had the board file or knew a little bit more. That could be, you know, some sort of a math processor, some FPGA, and it looks like there's another 2 unpopulated ICs over there, and I don't know what those did either. But this is some fine-pitched stuff, even for 2014. I'm glad it wasn't me. I'll tell you that much. Okay. I can't seem to get this out. It just spins. I was hoping to pull the rest of the connector apart or get the rest of the heat shielding thing off. So on the back side of this, to screw that in, you've got these 4 oh, there it is. It's just, I thought it was press fit. It was just taped on. So you've got these 4 bolts. And I doubt that I will ever be using this again for anything, but it does make an interesting conversation piece. So if I'm ever teaching anybody or talking to them about heat pipes, then we'll be good to go. All right. Set that off to the side. What trouble should we get into next? I do want to analyze these printed circuit boards, but I think I might be better off waiting until I have the microscope camera ready to go. I think we're going to really need to dig into these. And the same thing goes for this board. I think I'd be better off waiting until I hook up a camera for the microscope, which isn't a big deal. I've got it right here. All right. Now the only thing we didn't take apart was the hard drive, but since we're here, we might as well get it ready to go. You never know. I just might get excited and go take apart that hard drive under the microscope as well. Okay. Looks like we've got some security screws in there that we'll have to deal with. All right, so not the most educational teardown yet. We're going to pull out a microscope and come back at this and look at some of the principles of printed circuit board design that were utilized here, and some choices that were made that I think are interesting. Oh, that's cool. So there's some stuff left to do, but I think I need to adjust my video setup to do it. So we're not done. Oh no, dear reader, we are not done. We're going to come back at this with this microscope hooked up, and we're going to come at this again and finish going through and seeing what there is to see. I mean, we've got circuit boards, we've got hard drives. Maybe we can see some data. I'm kidding, you can't do that. Can you? No, you can't. And we've got all these boards, you know, memories and whatnot to look at, see if we can learn some best design practices and go from there. With that, I'm going to end today's live stream. I hope you've enjoyed it. We're not done. Oh, we're not done. And I hope that you set the little subscribe and remind buttons below so the next time I do one of these, you can watch it live and we can interact. You can ask questions or not. I don't know. I might not answer them. You never know. I'm kind of a crotchety old booger in my old age of 42. I don't know what I am. If you ever have questions, reach out to sales@aapcb.com and let us know if we can help you with anything, even if you want to talk to me or talk to research and development, anybody. Just hit up sales. They kind of handle all the workflow. Reach out. Let us know what we can do to help you. We'll help you. Take care.